Okay, so use of data booklet is relevant to this question. Okay. Reaction of Ki, potassium iodide, Ki, with hydrogen peroxide is represented here. Which statement about this reaction is true? First one is E naught cell is positive 1.23. How do you calculate this? Use the formula, right? E reduction minus E oxidation. Okay, so for I minus, it must be oxidized. There's no other way. It cannot be further reduced. So if it must be oxidized, right, it means that peroxide must be reduced. Okay, so again, go to the data booklet, look for the half equation where peroxide is on the left hand side. Okay, don't take my word for it. Go to your data booklet, look for peroxide on the left hand side. Actually, by coincidence, I'm already there because we're always looking at this part. You see, peroxide on the left hand side. So just choose this. Peroxide is on the left hand side. Then the iodine, where's iodine? Oh, iodide, sorry, not iodine, iodide. Next, on the right hand side. Oh, good. One on the left hand side, one on the right hand side. You just take the value minus off. Finish. Okay, so the left hand side is 1.77 minus 0.54. When you come back, you realize that it is 1.23. It's correct, 1.23. So statement 1 is okay. Statement 1 is okay. Basically, just do the calculation. How about statement 2? E naught cell becomes more negative when bromine is added to anode. So where's the anode, guys? Anode is oxidation, right? So it's added to the iodine half cell. What do you think happens when you add Br2 to I minus? What do you think happens? Displacement, right? Because Br is more reactive compared to I minus. So it will displace out because it's higher in reactivity. So what happens is that now you will get the Br minus half cell instead of an iodine half cell. Okay, so you have Br minus. Now go back to the data booklet, alphabetical, so it's on top. The I minus will change to this E naught. Okay, so going back to your calculation, right? Instead of 0.54, now you have 1.07, right? So obviously, the E cell becomes what? More negative. It's true, right? Yeah, becomes more negative. So yeah, absolutely. Absolutely. So it's now only 0.70. Okay, statement 2 is okay. How about statement 3? E cell becomes more positive when a few drops of silver nitrate is added to anode again. So this time round, we don't add Br2, we add Ag+. Guys must remember, when you add silver nitrate, right? Nobody cares about the nitrate. You're just adding silver plus. Okay, because nitrate not reactive. So silver plus you add to I minus, it will become what? Silver iodide, which is a yellow PPT. So if silver iodide is formed, right, what happens to the equilibrium with the iodine? Okay, so iodine is like this, right? The half equation, I minus. Okay, so if this is being used to precipitate, the AgI, which way will the equilibrium shift? It will shift to the right. Okay, and remember, if it shifts to the right, the E naught value, right, of this half cell will actually increase. Okay, so coming back to this equation, right? If it increase, it means that this number might become a bigger number like 0.60. Then what is the effect on the E naught cell? Mathematically. Is it obvious to you? It's obvious, right? Because 1.77 minus 0.6, you end up with a smaller number. Okay, so it actually becomes more negative, not more positive. So this is not correct, guys. This is not correct. So the third option is not correct. So our answer here is B.